Today in this video I will explain you what is work function. Now let's consider a metallic specimen. So this is a metallic body that is built up of many number of atoms. Okay, having a nucleus at the center and electrons revolving in the orbit. Now out of all the orbits an atom have, we know that outermost electrons are loosely bound to the nucleus. What is the reason? The reason is very simple, which is outermost electrons are kept at a very distance away from the nucleus. That is the reason it is called as outermost electron, right? Innermost electrons are very close to this, so they are closely bound, strongly bound. These are weakly bound. Now, whenever we are heating an element, what will happen? These electrons will get a higher energy. Okay, so they will vibrate, and what will happen with that higher energy? They will leave the outermost orbit because now they got such amount of energy so that they can come out of the electric field offered by the nucleus. So these are attracted inward and these electrons are revolving in the orbit. When they are getting higher energy, that comes out. So this will be the path. And while they are coming out, see, they will collide with another electron. For example, an electron has got higher energy, so this can be thermally excited, or see, the atmospheric temperature is a higher temperature because atmospheric temperature is 30 degrees Celsius, which is approximately 300 Kelvin. So 300 Kelvin is an excited state as compared to 10 Kelvin or 100 Kelvin. So at this temperature, many of the electrons in a metal are excited already, or I can say that they will come out of the outermost orbit. Now while coming out, so these electrons are free electron. These can collide with another electrons of another atom. So this electron, let's say they are coming out. Now while moving, why they are not coming out of the metal surface? So they have a tendency, if they collide with this, and after this, if these electrons are coming out, they can move in straight line and they can come out of the metal, right? But this is not possible, or this is not happening. Why? Because the moment an electron, so initially what is the net charge of this metallic specimen? 0, because whatever the number of protons that the metal carries, equal to that number we will be having electrons. So say for example, we have here in this case, let's say only one outermost electrons we are having. So 4 electrons we are having in 4 atoms and 4 protons. So 1, 2, 3, 4. So 4 protons. Say for example, 4 electrons and 4 protons. So these are the 4 proton, 1, 2, 3, 4. These are the 4 electron, 1, 2, 3, 4. Net charge is 0. The moment one electron come out, the net total number of, let's say this have came out, this has collided with this electron. Now there is a vacancy here, so this electron is not there. Now this electron has occupied this position. For example, this electron has came from this orbit and now collided with the electron which was there with the atom. So after the collision, this electron has occupied this space, and this electron, let's say they are coming in straight line, and here it is. So this electron was belonging to this atom before, and this electron was with this atom before. And the moment this happens, the total charge inside will become, see, 1, 2, 3, only 3 electrons, and 1, 2, 3, 4 proton, 1, 2, 3, 4 protons. What is the net charge? That is 1 positive charge. Now see, the moment it comes out, this positive charge will attract the electron backward. Because see, let's say the moment it has came outside and now it is here, the distance is very less. Now see, this is 1 positive and 1 negative at a very small distance. So the energy, or I could say that the attractive force will be very high, so that this electron cannot leave. Is that clear? Now the total, this will become positive charge, and this positive charge will pull it backward. So the electron will be here itself. That is the concept. Now, if the electrons are having sufficient high energy, okay, now see why the electrons cannot go outside, because these electrons are comparatively having lower energy. With this energy, this cannot overcome the potential barrier. So this can also be explained in this way. Electron will always be moving from weaker potential to stronger potential. Okay, so electron will move from weaker potential to stronger potential. For example, I have a positive charge here. Now I have an electron here. Now what is potential at this point? 1 by 4 pi epsilon 0 Q by R. So this is Q positive charge, right? Now here it is stronger potential. Why? The charge Q and 1 by 4 pi epsilon 0 is the same, but the R is less here. Okay, so it is a strong potential here, and here comparatively lesser, then this is very weak potential here. Now from this potential, from this place, electron will move inward. So whenever they are moving inward, their potential increases. Correct. Potential at that point is higher. Whenever electrons are coming inward, I could say that it is moving from a weaker potential to stronger potential. Now what will be the energy of this electron? We know that when a charge of Q is placed at a potential of V, then the energy will be QV. So here it will be having higher energy, here it will be having lower energy. Now here see, when the electrons are very close to the positive charge, it will have higher energy, and this energy will keep the electron inside. Now if at all if the electrons are having higher energy, so that it can break the potential barrier, it will move outside. I'll repeat it. See, now the electrons are here. The total charge of the specimen is positive. Charge of electron is negative. These are at a strong potential. Okay, it cannot be, it will not break at room temperature, because that electrons will not carry such higher amount of energy. But if at all if you are giving high amount of energy, this electron can break the potential barrier and will go out. So this is called as a electron emission. So how does electron emission happens? The electrons carrying sufficiently high energy, that is breaking the potential barrier and moving out. Okay, now this, so how can electron be out, how can electron attain such high amount of energy? So this can be done with the help of light. So light will give electrons a very high amount of energy, because light is carrying energy. Now when the light is having higher energy, or light carries a particular amount of energy, that is called as work function. Not all the radiation can make this possible. This is called as photoelectric emission. I will explain it, but as of now it is electron emission. Electron is emitted from a metal surface. Okay, so when a light comes and falls on an electron, light will transfer the energy that it carries to this electron, but that is only possible if the light is a matter. Now, so this itself is proving that light has got certain material behavior. Now, let's say light is a material, it carries energy. Whenever they collide with electron, that will transfer energy to the electron. Now, this electron will attain that energy, or will gain that energy. With that energy, that can leave the surface. Now, let's say, for example, this requires 10 joule of energy. Say for example, now if the light, this process, or only electrons with 10 joule of energy can move out of the metal surface. Now if this is having only 8 joule of energy, will this process possible? No, because see, this will get only 8 joule, and this 8 joule is not sufficient to raise its energy to 10 joule and break the potential barrier. But if I am giving a radiation of 15 joule, what will happen? See, out of 15 joule, the light radiation will come and will collide with electron, and out of 15 joule, 10 joule will be transferred, 10 joule will be used as a work function, or to just come out of the metal surface. Now, for this process to break the potential barrier and comes out, it requires certain amount of energy. That is what we have discussed here. That is 10 joule. Now what is remaining? 15 joule was the incoming radiation, energy of the incoming radiation. Out of that, 10 joule is used. So 5 joule is remaining. That is the kinetic energy of the object. Now see, the moment it comes out, 10 joule is used. Now with the remaining 5 joule, that will be used for, to move from one position to another position, or let's say that will be used for its velocity. Now when the energy is stored in its velocity, we can say that is kinetic energy. Clear? Now All this process, all these things I will explain in detail in coming lectures, but as of now you can understand one thing, that work function of a metal is the minimum energy to be given to its electron so that it leaves the surface without having an energy. Now 15 joule will also take an electron outside, and 10 joule can also take an electron outside. But when I am giving 10 joule, see, for taking the electron outside, the 10 joule will be used, and that electron outside will have zero velocity, because 10 joule is the work function. What is work function? Minimum energy required for an electron to comes out of a metallic surface. Now out of 10 joule radiation, when it falls on an electron, out of 10 joule will be used as a work function. What is remaining? 0. So it has no kinetic energy. But if the radiation carries 15 joule energy, out of 15, 10 joule will be used as work function. What is work function? The energy required for an electron to comes out of a metallic surface. Now what is remaining? 5 joule is remaining. That 5 joule will become its kinetic energy. Okay, so basically the 10 joule is the work function. It is the minimum energy. 10 joule can make an photoelectric emission possible. Here in my example, 15 joule can make it possible, but 8 joule cannot make it possible. So the minimum energy is 10 joule here. Any radiation that have more than 10 joule can make this electron emission possible. Thank you.